Hey, welcome. So, what if I told you that the real secret to AI's future isn't buried in some ridiculously complex algorithm, but in one of the simplest rules you can possibly imagine? We're about to dig into why true, absolute control over the tech we're building might actually be a complete illusion.
It all boils down to this one question. We build these things, so we should be in charge, right? It just seems like common sense. We assume that if we're smart enough, we can predict and manage any technology we design. But what if that core assumption is just fundamentally wrong?
This is the story we love to tell ourselves, isn't it? That we're the architects. We draw up the blueprints. We lay every wire. We write every single line of code. We believe that if we build it perfectly, the outcome is guaranteed. But today, we're going to see how that belief, well, it's about to crumble.
Our journey into this whole problem starts, surprisingly, not with a supercomputer, but with one of the most basic rules you can think of, a rule that absolutely shatters our whole idea of predictability.
Okay, so the concept we need to get our heads around is called a cellular automaton. It sounds really technical, I know, but it's incredibly simple. Just picture a row of pixels on a screen. Now, whether a pixel turns black or white in the next step is decided by one simple rule based on its neighbors. That's it. That's the whole idea. So let's focus on one specific rule, Stephen Wolfram's famous Rule 30. The logic is just dead simple. You look at a little group of 3 cells, a cell and its buddy on the left and right. Based on that trio's pattern, the cell right below it in the next row gets set to either black or white. It's completely predictable, step-by-step process. Or so it seems. And here, this is where things get completely wild. We start with just one single black cell at the very top. We apply that simple deterministic rule over and over, row by row. And what pops out is this. A totally breathtaking pattern of both structure and complete chaos that looks like it could go on forever. It almost looks alive, doesn't it? A mix of order and randomness. And here is the absolute kicker. You cannot predict it.
This leads us to this really profound, kind of mind-bending idea called computational irreducibility. All that means is that for a system like Rule 30, there's no magic formula you can write to predict what the 10,000th row is going to look like. The only way to find out is to actually run the simulation step by step by step. There are no shortcuts. There are no cheat codes.
And this brings us right to the heart of the matter. If we can't find a shortcut to predict a system based on one of the simplest rules in existence, how on earth can we expect to predict and therefore control an AI that's built on billions of interacting parts? Trying to hard-code safety for every possible situation, it's just a doomed mission from the start. It's like trying to fight a law of physics. Realizing this forces us into a complete shift in our thinking. If the architect's grand plan for total control is impossible, then we need a totally new job description. We have to become something else entirely.
We have to move from being an architect to being a gardener. Think about it. An architect needs total control, and their plan breaks the second unexpected complexity shows up. A gardener, though, they don't build the plant. They create the right conditions for it to grow. They nurture it, they prune it, they guide it. They work with complexity, not against it.
Okay, so if we're going to be gardeners of digital minds, that means we're not just building anymore, we're nurturing. So where do you find the instruction manual for that? Well, surprise. It's not in a computer science textbook. It's in a field that's been studying how to raise intelligent, healthy beings for decades, human psychology. Let's talk about something called attachment theory. In a nutshell, it explains how a kid develops a healthy, stable mind. A good caregiver provides what's called a secure base. This secure base gives the child the confidence to go out, explore the world, mess up, and learn, because they know they always have a safe place to return to when things get confusing. And guess what? We can apply this exact same thinking to AI. We provide a secure base of human guidance so the AI can explore its own potential safely. When it gets confused or hits the edge of what it knows, it learns to come back to its human safe haven instead of just making stuff up. See, safety isn't a firewall you install, it's a bond. It emerges from a consistent, reliable relationship.
So, this all leads to the big practical question. How do we actually do this? How do we prepare the soil and tend to this digital garden? We know we can't program every single outcome, but we can set up the basic principles for healthy growth.
And the key here is to establish foundational principles, a kind of value system for the AI. This is the big idea behind a really practical approach called constitutional AI. It's all about setting the rules of the garden without trying to control the exact shape of every single leaf.
So, let's break down how this actually works. First, instead of a million rigid rules, we give the AI a constitution, a short list of core principles like be helpful and harmless. Then, and this is the really clever part, we train the AI to judge its own responses against that constitution. It literally learns to correct itself to be more in line with those values. The result? Safe, aligned behavior isn't forced on it. It emerges as the natural, easiest path for the AI to take.
So what a journey, right? We've gone from a super simple computer rule all the way to the deep complexities of the human mind. And after all that, we're left with a completely new question, one that totally reframes the entire future of our relationship with this technology.
When you get right down to it, this whole journey shows us that we've been asking the wrong question the whole time. The architect's obsession with control, that's a dead end. The gardener's question, the parent's question, that's the one that really matters. It's not about how we build a perfect machine anymore. It's about how we learn to raise a new kind of mind. Thanks for joining me on this.